Now, what we're looking at is the eye topic. So let's look at this. Pigeons are birds that eat seeds. They are hunted by predators called hawks. We need to use this information throughout the food chain. So you've got some seeds. I like to write the word seeds in case they can't figure out what I'm doing. Then you've got the pigeon. Write the name pigeon. And then you've got the something like this. There you go, hawk. Right, now you need to finish this off by drawing arrows pointing towards where the energy is going. So the birds are eaten, no, the seeds are eaten by the bird, and this bird is eaten by the hawk. Right, let's move on. Right, so what they're saying is pigeons often feed in small groups. The size of the groups of pigeon affects the success rate of the hawk. Basically, what happens is the more pigeons there are, the more pigeons there are, the more chance of you getting caught. I've done this in another video, but let's run with it. It's there. So if you've only got one pigeon, the average distance when a pigeon sees a hawk is 3 meters away, and the hawk has got an 80% chance of catching it. If there's 2 to 10, you can see it 16 meters away, so it reduces the chance of the hawk catching the pigeon. 11 to 50, 30 meters away, 17%. And if you've got more than 50, what happens is someone can spot it 40 meters away and there's only a 6% chance. So basically what happens is it's like there's loads of pigeons. That one's eating, that one's eating, that one's eating, that one's eating. These 5 are not eating. I'll just say these 4 are not eating at that time. So there's 4 of them looking up and they'll see the pigeon from further away. Now if there's many more, just say that one's eating, that one's eating, that one's eating, that one's eating. There's now, look, all these here, all these pigeons that are looking up. So you'll see it from even further away. So you've got more chance of escaping. So they'll fly off, they'll look at what's going on, and then they'll fly off. And then if you're loads of them, more than 50 in a big group, there's even more eyes keeping an eye, and you'll see the hawk from even further away. They fly off, you're gone. There's only a 6% chance. Right. Use information to describe and explain the relationship between this size of pigeons and the success rate. So the greater the number of pigeons, the lower the success rate. Success, that's double S, success rate for the hawk. And why is that? Because the hawk is more likely to be seen. The hawk is more likely to be spotted early. To be spotted early. Right, okay. Describe the changes that would take place in the eye to help the pigeon see an approaching hawk. So what you have a fat lens and you have a less fat lens. A fat lens, they call it more convex. And because it's thinner and it's this shape, it is more, oh, whoa, less convex. Right. So what you do is you have your lens, you have your suspensory ligaments, you have your ciliary muscles. There. Right. So what happens is, from a distance, from a distant object, the light rays that come in are almost parallel. So there's very little bending that needs to be done. Very little bending. There you go. And then it'll go hit the retina. That's the retina, the back of the eye, and it can focus there and you can see clearly. The pigeon can see. Now, yeah, let's do that. So you've got a lens, you've got your suspensory ligaments, you've got your suspensory ligaments, then you have your ciliary muscles, you have, that's supposed to be attached there, you've got your ciliary muscles. The hawk is here, it's now close, the image is close, so the light is coming in at this angle and it's coming in at this angle. Now it needs to focus here on the retina. So now look, the light's going that way. Before it was going straight. So now it has to bend even more. So it has to bend much more to get there. Much more. So this lens needs to become much fatter. Which color? Right, it needs to become much fatter. Right, I'm going to use the word fatter or wider, or better still, more convex. That's the best word to use, I think. So then what happens is the light can go up and bend down to here, right? So the light can go in and bend. Sorry, it's going in through the same place. Otherwise, what happens is the original blue ray will end up focusing back here because it's not bent enough and it'll be out of focus. That's dangerous for the pigeon. So a few things happen here. These things here are called, let's use this color, it's a nice color, ciliary muscles. I can never spell that. This is your convex lens. That is your lens. And these here are the suspensory ligaments. There you go. Step 1. These ciliary muscles contract. So when you're going from far to near, this process is called accommodation. Yep. So the ciliary muscles, what do? They contract, not relax, contract. What happens then? This makes the suspensory ligaments slacken. Not relax, but slacken. Slacken. What does that do? This makes the lens fatter or more convex. This bends the light more to focus image on the retina. Number 5. This process is called accommodation. There you go. Right, describe what happens to protein in a pigeon meat in a stomach. So meat, whenever you see meat, think of protein. Okay, let's move on. Right, in the stomach. So the okay, this is I agree, this is more to do with digestion, but let's quickly do it. The hydrochloric acid has a low pH value, so the pepsin released must have a low optimum pH. The protein is digested into, right, I like to use the word amino acids, that's always in the mark scheme, or you could say into peptides. I can't spell, what's going on? Peptides. Okay, we'll leave that because this is more to do with the eye, so let's move on. Right, the diagram shows section through an artery and a vein. What is this doing here? Listen, let's run with this quickly. Use information in the diagram shown are 3 ways the structure of an artery differs from the structure of a vein. Okay, so what we can say, let's look at a vein. A vein has a large lumen. This means this gap in the middle. A vein has a thinner wall because it has to withstand less pressure, because there is less pressure from the blood. Less blood pressure. Let's write that down. Right. The vein, it says, and use your own knowledge. The vein has valves to stop the back. Right, let's move this up so I can write it properly. Move the back to stop the back flow of blood. There you go. So there's 3 things. There's another as well, but what you can say is it has a less muscular wall because it doesn't need to stretch far, and the muscular wall brings it back into shape, especially for the artery which is up there. Right, there you go. Name the parts. Right, this is an interesting one. So let's name the parts A, B and C. I know A here is the lens, B is, they're pointing to this, is that the cornea or sclera? I don't think. So when it comes to the front, it becomes the cornea. So it's not sclera. And that's the iris, and the C is the retina. So let's quickly check that. Yep, I thought so. This is the cornea. I thought they were pointing to this, so that's the sclera, and then it becomes a cornea here, this bulgy part. Okay, that's fair enough. So let's look at this now slowly. So you've got the white part, the sclera. So that is not the sclera. You have the black bit which absorbs light, stops multiple images forming. It's called the choroid. You've got the retina here on C, retina. Then you've got this little thing here. This little thing here, that's called the fovea. It contains rods for focus. They can detect. They're for black and white images. And you've got cones which detect color. You've got the optic nerve here. This is all they want you to know. And where all these bundles of fibers go in, there's no cells to detect light. That point there is called the blind spot. Okay, so you've got here, right, you've got suspensory ligaments here. Suspensory ligaments. Whoa, come on. Ligaments. Right, and you've got here, you've got the iris, the hole in the middle, the pupil, and then you've got this here, the conjunctiva. Right, okay. That's just taking it a stage further. It's like a revision video, this. When you move from a bright room to a dark room, you cannot see very well for a while. A brief time, a change in the iris helps you see more clearly. The iris contains muscle tissue. What is tissue? Okay. Whoa, what's going on? I can't even write same cells, a group of same cells working together to perform a task. Yeah, that's it. Right, so let me just go through that, because although it's not related, a group of same cells working together to perform a task. Yeah, right, okay. Describe the changes you would let's try that. Describe the change that will take place in the iris when moving into the dark room. So you're going from light to dark. So what happens is you've got circular muscles and you've got radial muscles. Right, when these circular muscles contract, these are circular muscles. When they contract, this gap here, it gets smaller. And that gap is called the pupil. Right, so when the circular muscles contract, these green ones, the green muscles are called radial muscles. Muscles. They relax. So what happens is you get less light entering, because the intensity, it's intense light, it's a bright room, so you need the less amount of it, a lower amount of it. You need less of it. So it's a 3 marker. So what happens is the circular muscles contract. Whoa, okay, let me check that. I do this all the time. I should read the question and end up waffling somewhere. So the circular muscle, so I'm going into a dark room. So the circular muscles are going to relax. That means the gap gets bigger, right? So and the radial muscles contract, right? So what does that mean? This means the pupil gets bigger, but you don't use the word bigger, you use the word dilate. The opposite of dilate, you don't say get smaller, you say constrict. So the pupil dilates, letting in more light. Okay, you've got that. Right, we've had 23 minutes of this. Right, okay, we'll call it. Let's have a look. Yeah, okay, another video. Let's do another video. We won't rush this. I think this will be useful for you. Yeah, okay, we'll call it quits there. We'll do it on another video.